The ultimate goal of this experiment is to determine the concentration of an unknown hydrogen peroxide solution. We can do that by titrating against potassium permanganate. Nice, right? One titration, should be easy. Well, no, science isn't always that straightforward. Because potassium permanganate decomposes under neutral conditions, we'll have to first standardize it against a more stable standard. In part A, we'll first prepare our potassium permanganate solution. Then we'll move on to part B, where we prepare a reference standard of sodium oxalate. Then in part C, we'll use the two together and standardize the potassium permanganate against the reference standard of sodium oxalate. Then finally, in part D, the last titration, we will use the standardized potassium permanganate to determine the unknown concentration of the hydrogen peroxide. If you're newer to the laboratory or perhaps a little rusty, I highly recommend checking out our video on laboratory equipment. It has a lot of useful information and tips on how to use the equipment, as well as some of the procedures that you'll be required to do in this experiment. The procedure for part A is quite straightforward. What I've got here is a beaker, and I've measured out about 1 gram of my potassium permanganate solid. I've also got a shot bottle with a glass funnel in the top, and there's a glass wool plug there that should stop the transfer of any solids into our solution. So what I'm going to do is take about 50 ml aliquots of some deionized water, give it a light swirl, and wait for the solids to settle down. Then I'll take a glass rod and lay it across the lip of the beaker to decant, hopefully separating the solids from the liquids. It should also help the liquid run down the rod rather than spilling anywhere. It's okay to leave a little bit of the liquid behind because you're just going to rinse and repeat until a total of 300 mils has been added to the shot bottle. For part C, we'll need to do a hot titration. So for each one of your runs, you'll need to take your oxalate and your sulfuric acid that you've combined in your conical flask and heat it up over a Bunsen burner. The basic setup includes a fireproof mat, the Bunsen burner itself, a tripod, and a gauze mat to distribute the heat of the flame. This right now, you can see the orange flame is a safety flame. If I were to open the valve at the bottom, allowing more oxygen through, it turns to a much more intense blue flame. Anytime you walk away from your reaction, please turn it back to a safety flame for everyone's safety. So we'll stick the gauze mat on and we will stick the reaction on. Now, once this is heated up, obviously you don't want to touch anything directly, so what we can do is make a collared handle, and we'll do that by just tearing off a piece of paper towel and folding it in half a few times until I get something like that. And what we can do is just wrap it around the top and pinch the collared handle right near the top of the flask. While the reaction's been heating up over the Bunsen burner, I've gone ahead and set up this titration equipment, which includes filling the burette with potassium permanganate and running out a few mils into this waste beaker just to fill up this lower section. Now that I'm done, I can take away my waste beaker, grab my flask with the collared handle, stick it underneath the tap, and begin to titrate. It's important you swirl at all times, making sure that the temperature in the flask is above 60 degrees. If not, you stick it back on the heat and then resume once back up to temperature. What we're looking for is the pink color of the permanganate to stay constant and not disappear for at least 15 seconds. For part D, acquire one of these volumetric flasks that contains hydrogen peroxide and fill it up to the mark with deionized water. You'll take the solution and dispense 3 aliquots of 25 mils into 3 separate conical flasks, into each of which you'll also dispense 45 mils of 1 mole of sulfuric acid. This time we're doing a room temp titration, so we don't need the Bunsen setup. It's important to take care with this one, however, to not swirl too vigorously. If you over-agitate the solution, you'll break down the hydrogen peroxide and affect your result. So that's experiment 2 in a nutshell. Now that we know that not all reagents are created equal, we know that we can use a stable reference standard to standardize an unstable reagent. That's it from me, and I'll see you in the lab.